Hello, everyone. My name is Rahul, and I'm with Loft Labs. I head growth marketing here at Loft. And today we have with us Costas, who is going to give us an amazing presentation on virtual clusters for development and CI/CD workflows. Just a few housekeeping items. If you have any questions, put them in the chat. You will see it on the right of yourself on your screen. And then mostly we will get to your questions at the end because Costas has a packed agenda. So with that, Costas, over to you.
Thank you very much. So yes, today I'll be your host. My name is Kostis. That's the correct pronunciation. I'm a developer advocate at Codefresh. Codefresh is an enterprise solution for Kubernetes deployments, and we will see some of its features along with Loft. I'm also working a lot in the open source area. I'm a maintainer in Argo Rollouts, but we're not going to talk about Argo Rollouts today, unfortunately. I love virtual clusters. I think it's one of the most interesting projects right now, and it's something that will change a lot, your workflows or your processes if you adopt it correctly. And today we're mostly going to focus on, Kubernetes and virtual clusters and containers. So we have a packed agenda because essentially we don't have just one demo. We have 4 demos with some theory in between. And the demos are structured in a way where each demo builds on top of the previous one. So the first demos might look a bit, let's say, simplistic, but the last one is close to a real-world scenario. So I didn't, want to just put everything in a single demo. I want to show how I'm building things from start to finish. And there is some theory in between. As Rahul said also, feel free to ask questions. I'm one of the people that believe that there are no stupid questions, only stupid answers. So even if you think that asking the question will make you, I don't know, look not knowledgeable in this area, just ask it. And at the end, we'll try to answer them all if we have enough time. But please, ask. And if I say something that I take for granted and you don't understand what I'm saying, just ask. It's much easier than not saying anything. So I know that several presentations start and they go right into tools and solutions and how you can solve problems. And it's fine, tools are important, but tools only give us value if we help people, because this is why you're here, to help people. So I'm going to start the presentation from a different perspective and talk about the people first, then their problems, and then their tools, which I think is a much more natural way of doing presentations. So these are the types of people that we are going to talk today. They are 3 different personas, and maybe you are already familiar with them or you are even part of one of them. We have developers for building code, operators for running systems and keeping systems healthy, and then we have everybody else. Maybe it's team leads, department leads, CTOs, DevX people, everybody else that is involved in the software delivery process within a company. And as you can imagine, these people have different needs, different ideas, and different priorities. So if we focus on developers first, what do developers want? They want to write code. That's the only thing they want. Write code and send features to production. So essentially, they like to move fast. They like to, let's say, break things. And they don't really care about Kubernetes. That's not, let's say, it's not important for them. They care about writing code and sending it to production. And if it's a VM or Kubernetes or Docker Compose or whatever, that's not really important for them. They want to focus on writing code, and not writing code is something that they don't really like. So they want an easy way to create infrastructure for their own needs. So ideally, what they would like is to see a button that says, create a new environment for me or a new database. They click the button, they get their database or their cluster, and they don't know what happens behind the scenes, and they don't care about what happens behind the scenes. So these are the needs of developers. Then at the other end of the spectrum, we have operators, and these people have different names. Some of them call them operators, SREs, system administrators, DevOps people, infra people. There isn't like a common agreement here. Name them as you want. Essentially, I describe the people that keep systems running. So for them, the biggest priority is to have systems ready and serving traffic all the time. Uptime is super important for them. Essentially, they are let's say, in contrast with developers, they want to move slowly. For them, deploying too fast in production is not something they really enjoy. They hate, tickets and opening tickets and closing tickets and working with tickets. And most important of all, usually they don't like buttons and UIs and, let's say, friendly dashboards. They prefer automation. They want to automate everything. That's their main goal, to automate all their daily processes. So they are the people that like CLIs, scripts, automated processes, pipelines, and everything that has nothing to do with the UI. And last, we have the other people in the company that are dealing with the software delivery process. Here, as an example, I've chosen DevX, if you have this kind of profile in your company, but maybe it's your team lead or your CTO. And essentially, they care about velocity, not only velocity of sending features to production, but also how many failures you have in production, how much time it takes to onboard a new developer, how much time it takes to form a new team, how much time it takes to form a new service. So they are not, let's say, involved with writing code or deploying software, but they are interested in the overall processes. So these are the personas that I'm going to talk about. And essentially, the main theme from this presentation is that vClusters offers something for everybody. So even though in theory these three personas are completely different, vClusters can help all three personas. So what are vClusters? I would assume that if you are here, maybe you already know what is a virtual cluster, but just to be certain that everybody's on the same page, I'm going to talk a bit about vClusters. And this is the official diagram that Loft has in their documentation about vCluster, which is great if, let's say, you are a developer or you want to extend vCluster. But personally, I don't really like this diagram, so I'm going to show you my own diagram, which I think makes things a bit more simpler to try to understand what is a virtual cluster. So here I have two clusters, and on the left, it's the standard Kubernetes deployment. You have a single real cluster. It's a single cluster, and it has different namespaces where people, let's say, deploy their applications. There is a Kube API for communicating with the cluster, and everybody's working with namespaces. And this is, let's say, the most common way of working with a cluster, even when you have multiple users. And on the right, I'm introducing virtual clusters. And you can see that right now, in its namespace of the parent cluster, there is a virtual cluster. And even though this virtual cluster is, let's say, constrained in the namespace, it has its own Kube API, and it answers to all the API requests of any tool that is compatible with that API. So customers can still work with these virtual clusters, and they don't understand that the cluster that they are talking to is not a real one. I mean, it's not a secret. Maybe you can do some things to discover it, but all tools should be compatible. It's a real Kubernetes cluster. And the first advantage that you can see right away, if you have ever worked with custom resources, when you're working with a single cluster, the custom resources are global. They are shared between everybody. You install them once, and usually you have problems with conflicts if somebody wants to use a newer version of our CRD or an older version. With virtual clusters, because the CRDs are now installed per cluster, you have, let's say, greater capabilities of what kind of software you want to run. And actually, virtual clusters allow you to run a different Kubernetes version. So maybe it's different than the parent one, or even, let's say, a different distribution. So it doesn't have to be the same distribution of Kubernetes as you're using. So I think this is a better explanation on what are virtual clusters. And usually the first question that you ask when you see virtual clusters is it slower than using a real cluster? And I understand this question because, this is how we think, especially when you're coming from virtual machines where there is some overhead, or if you're using containers, and again, there is a minor overhead. So in this case, I'm going to say that all the workloads of the virtual clusters are actually running in the namespace of the parent cluster. There is no indirection there. So the Kube API that you're talking to is, let's say, your own, but the workloads get scheduled in the parent cluster. So there shouldn't be any performance hit there. And actually, if you look at the diagram on the left, maybe if you have a super popular cluster and you have too many users communicating with the Kube API, you might have a bottleneck there. But if you're using virtual clusters, because each user is using their own Kube API, maybe it's even faster to use virtual clusters in your company, especially in multi-tenancy scenarios. So not only virtual clusters are not slower, but depending on your use case, they might be even faster. So I think this is a really interesting feature and one of the reasons I love virtual clusters. Okay, so we know we have a virtual clusters. What do we use them for? For me, this picture shows it all like it's a Swiss Army knife. You can use it for everything, for many scenarios. It's one of the most, let's say, powerful tools ever. Here I have some of the most popular use cases. So the most classic one, and we are going to talk a bit about this today, is to create environments for developers. And developers will be, super happy if they have a cluster that they can do whatever they want, and they think they have access to all the namespaces, but they do not, and they can install their own CRDs, their own applications, or whatever else they need. Then you have multi-tenancy scenarios where it's not, temporary environments, but it's permanent environments. You have, let's say, a company with many customers, and you want to give a service to its customer, and instead of using isolated clusters, you put them all in a single cluster. This is actually one of the use cases that we have at Codefresh. So at Codefresh, we are using vClusters for our own product. Then you can have things like testing different cluster versions, because remember I said one of the advantages is that you don't have to constrain yourself to the same version as the parent cluster. So maybe your parent cluster is Kubernetes 1.23, and you're launching a virtual cluster that is also 1.23, or a virtual cluster that is 1.22 or 24. You can go some versions up and down. So you don't need to launch a real cluster in order to launch different versions. And the last one, which is also popular because of the economy right now, is for cost reasons. Virtual clusters are part of a main cluster. So if you launch 20 clusters, let's say 20 virtual clusters, you still pay the control plane for only one cluster, the parent one. So it's very easy for you to have a large number of clusters, and especially for scenarios where, let's say, you want to have many clusters running all the time, you can now do it and you don't care about the control plane costs anymore. So these are some of the scenarios that we have seen so far. And I'm not going to talk about all these scenarios. I'm really lucky right now. A lot of people have talked about these scenarios. If you go to the CNCF YouTube channel that is on the link there, and you simply search for vCluster, you will find already several presentations that talk about some of these cases. The first one is the one I talked about. It's the one that we use internally. This was a Cubicle presentation. It talks about multi-tenancy, but you can see also some other videos that talk about review environments or stuff like that. So if you were interested about a different use case than the one I'm going to show today in the presentation, fear not, there are several videos out there that explain them. And I think it's also a testament to the capability of virtual clusters, like how many companies are using virtual clusters for different scenarios. I think the two middle ones are from Adobe. Like Adobe really likes virtual clusters. Okay, so we said we're going to talk about the people. We have talked about the people, and then we talked about the tool, and now let's connect them together and see how the tool can help the people. So Loft, apart from virtual cluster, the infrastructure also has a commercial product that is what developers would like a very friendly dashboard for managing virtual clusters. Now, I know what you will ask here. You will say, hey, you just told us that developers don't really care about Kubernetes. So why should we provide them a dashboard for creating Kubernetes clusters? And yes, you are correct. This is what you should do. Unfortunately, there are some scenarios where developers still need to be exposed to Kubernetes. The most common example is you have a complex application which maybe needs to be deployed to multiple namespaces. So at the very least, they should know about namespaces. Then maybe the application itself needs to be tested on different Kubernetes version, or the application itself is a Kubernetes operator. So it has to work with Kubernetes. And this is, again, something that developers must know. But I think the most common scenario is speed. Like if you are familiar with how cloud providers work, usually when you create a real cluster, maybe it takes 15 minutes or 20 minutes, which is too slow. Nobody likes to wait. And I think developers really like it when they get a cluster in half a minute or 1 minute. So it's okay, I think, in some cases to give them this abstraction and have them learn at least some basic Kubernetes concepts in order to make their life easy. Okay, so time for the first demo, and I'm going to show this dashboard that I'm talking about. So now we are focusing on developers, and remember I said developers don't like anything else apart from code. If they need something else, they would like to have a button. So this is the Loft dashboard, and I'm not going to talk too much about it because it has great features that are already documented in the YouTube channel from Loft. But one of the central things that you can do here is, of course, you can create spaces, which is the same thing as namespaces. That's fine. But the magic thing is this button, create virtual cluster. So as a developer, I log into this UI, and without caring about kubectl configs, authentication, service accounts, or whatever, I have a nice button that I click. I can optionally pick a template on the cluster, and if you're an administrator, you can put different templates. And let's say here I put my name of the cluster, so webinar demo. And then I click a button and boom, that's it. There is a new cluster created just for me that I can create. Now, of course, this is the basic use case. You can add here security. You can define exactly what goes into the cluster. You can create teams. You can create projects and set the security and make developers see only the products that they want. Loft also has a very nice CLI. So if you don't like the UI, even if you're a developer, you can also use the CLI and connect to the clusters and do whatever you want to do. So there, the cluster is ready. I got a cluster just for me in maybe 30 seconds. So developers are super happy about this. And I can equally delete the cluster when I don't need it anymore. So developers should be happy with this because they can get, cluster quickly, but this is only half of the story. Like, okay, I got a cluster. What do I do next? The next obvious thing is I want to deploy there. And usually developers have, let's say, two needs. Either you want to deploy while you're developing a feature, so doing local development, or you want to deploy as part of a CI/CD pipeline. Now, we don't have time to show both scenarios. So today I'm going to show the second one. And this is the title of the webinar, using CI/CD pipelines. But if you want to know about local development, the next obvious thing would be to look at the other products from Loft. There is a DevSpace and DevPod that they do exactly that. And I'm super happy that I saw last week there is a YouTube video in the Loft YouTube channel that explains exactly the scenario, how you create a cluster with Loft, and then how you use it in order to start development using your IDE. So as far as I'm concerned, okay, developers should be happy right now for local development. They get what they want, at least until the feature is ready and needs to be pushed. Okay, so let's go back to the slides. So this is Loft. You should check it out, especially if you are a developer. These are also the links to the other two products, DevSpace.sh and DevPod. As I said, there is no time, to show all the features. There is also another interesting integration with Argo CD. And remember, I work as an open source contributor for Argo CD and Argo Rollouts. So that's also a super exciting feature. But let's say that we have covered developers, like developers who want to focus on code. They want to click a button and get what they want. We need to also see how virtual clusters are relevant to the other two personas. So remember I said that operators or SREs, they are the exact opposite. They don't like UIs, they don't like buttons, and they prefer to automate stuff and to do things automatically with scripts. So Loft, again, is one step ahead. So apart from the UI that we just saw, there is also a very friendly CLI that you can use to create clusters. There is also a Helm installation. And actually, the one thing I did mention is that Loft itself is installed with Helm, so it's super easy to install it. But the most interesting scenario for me is to use Terraform. And I'm, let's say, pretty amazed that I've searched about how to use Terraform with vClusters. And right now in the YouTube channel of Loft, there are exactly 0 videos on how to do it. So hopefully this webinar will go into this channel and you will know how to use it with Terraform. And why I'm talking about Terraform? Because it's one of the most favorite tools of infra people, of SREs. People have invested a lot in Terraform, especially when it comes to infrastructure as code. So usually when they want to integrate a brand new tool to their own environment, the first question they ask is, how can I do it with Terraform? And in theory, you could just say, no, you create your own provider. No, we don't need to do that. Loft has already created a provider for Terraform for virtual clusters, and you can see the link there. And this allows you to use your existing Terraform infrastructure, which you should already have, and manage your Loft instance. And I'm going to talk about virtual clusters today, but every other, let's say, Loft construct, such as the projects or the spaces, can be also managed with Terraform. One word of warning: Loft has just released version 3.x, and the Terraform provider right now contains support for both this version and the previous version. So make sure to match your Loft version with the Terraform version that we are using. As you can imagine, I'm saying this because I had an issue where I'm using constructs for Loft v2 while I had the latest version. So a virtual cluster instance is Loft v3, and this is what we're going to see today. So how it works, if you have never seen Terraform before, it's essentially configuration language, DSL, where it describes things declaratively. It looks like JSON. It's not exactly a JSON. It's HCL, which is a special language to HashiCorp. And essentially, you describe what things need to happen, and then Terraform takes care of all the details. So in our example, there is a provider for Loft that you see there. And then you say, I want a cluster, and you describe its namespaces, maybe where the project goes, and stuff like this. And then you apply it with Terraform. So let's go to the second demo. So here, I have already a repository. This is public in GitHub. I think I have the link later, but you can see it is not something private. And it has the code from all examples. The example that we are going to talk about today, right now, is super simple. There is only one Terraform file that you can see here. And essentially, I'm saying, hey, I'm going to use the Terraform provider for Loft, and I define my clusters. And you can see this count here, and you can understand why this is important for operators. Because let's say I want to create 20 virtual clusters. I'm not going to go to the UI and click a button 20 times. I want an automated way. So this is a standard capability of Terraform. Here I have an example 3 because I'm in a very small cluster. But in theory, I could have 20 or 25 or 1,000 or whatever. So now, not with a single click of a button, but with a single Terraform command, I can create 3 clusters in my Loft instance. 3 is the example I'm going to use, but it could be 20. And you can see here Terraform says, hey, I'm going to add 3 things once you enter yes. So I enter yes, and now Terraform is creating the cluster. So I can go back to my UI, and you can see the clusters here getting created. So if I'm an operator, and let's say a developer comes to me and says, hey, I need 20 clusters, and I'm not going to click the create button 20 clusters, you say, that's not a problem. Let's use Terraform, and let's create the clusters right now. And if you're familiar with Terraform, you know that creating something is super easy, and also destroying something is super easy. So I can also run the destroy command, and just as easily as I created the clusters, I can also delete the clusters right away. So it's super easy to create and delete clusters on the spot, which is exactly what operators need. They want to create stuff quickly, tear it down quickly, and maybe if you want to do a quick test, you can run it right away. So this is how Terraform works with virtual clusters. So let's go back to the presentation. This is the link of the GitHub repo that has all the examples. So if you want to see how this code works, you can go there. Okay, so moving on, that's fine. I mean, we have automation, but in the real world, it's not a good practice to run Terraform from your workstation. Like, you don't need to have Terraform on your workstation. And also, if you're familiar with Terraform, there is a big question what you do with the Terraform state, which is what Terraform is using to store the existing state of your infrastructure. And usually what you want is to have Terraform running centrally somewhere, and also the state running centrally somewhere. So that example is great, the previous one, for understanding how Terraform works with virtual clusters, but it's not what you would do in a real company. So what should you do in a real company? So this is where Codefresh comes in. Now, Codefresh, like Loft, is a huge project with many capabilities. It has 3 modules, the CI module, the CD module, and the GitOps module. I'm not going to talk about all the modules. Essentially, today we're just going to talk about pipelines. And Codefresh pipelines are Docker-based. So there is here is a pipeline example, and it's a box that you see is essentially a Docker container that you run stuff. And one thing that is different for Codefresh is that it's integrated with Docker registries and Kubernetes clusters, and I will explain why this is important. Now, again, I know what you will ask. You will say, hey, I know that you're working for Codefresh, but why are we looking at Codefresh and we're not using GitHub Actions or Jenkins or TeamCity or CircleCI or something else? These are all great products, but they are, let's say, generic VM products that were created mainly for virtual machines, and then they try to adopt to Kubernetes and containers. While Codefresh was created for containers and Kubernetes from scratch. So here I have a very simple example of the exact same pipeline that builds a Docker image. And you can see on the left, in GitHub Actions, you need to deal with Docker authentication, see how you can access the registry, and then push the container. While the Codefresh pipeline is 1/3 of the size, and it just says, hey, build a Docker image and push it. And you can see there are no credentials, no passwords, no nothing. I'm just mentioning a Docker registry by name. And the same thing can happen also for Kubernetes. So again, I have on the left a pipeline for GitHub Actions that deploys to a Kubernetes cluster. And you can see a big part of the pipeline is authentication, like how you get access to the cluster, how you get a kubeconfig, and then how you deploy. And again, the Codefresh pipeline is super simple. It just says, I'm going to deploy to a Kubernetes cluster by name. So these advantages will come evident in how we are going to use Codefresh and virtual clusters together in order to give something to everybody, both developers and operators. So what's the magic sauce? The magic sauce is that Codefresh has a special settings screen where usually the operator goes and installs once a piece of infrastructure, so your Docker registries or your, let's say, Kubernetes clusters, and then everything is referenceable by name. So no credentials are in the pipelines. So let's go back to the demo. So here I'm again an operator, and using Terraform on its own is fine, but now I want to automate Terraform itself. So I'm not going to run Terraform from my CLI. I'm going to run it from Codefresh. So here I have a Codefresh pipeline, which essentially says, hey, clone the source code, get access to the cluster, and you can see there are no credentials here. I'm just saying I'm going to use my real cluster, and then it runs Terraform. And this runs the same example as before. It creates several virtual clusters that you will see in Love. So this pipeline is centrally in Codefresh. I don't need to have Terraform on my laptop. I don't need to know the credentials to the cluster. Everything is here. I run it, and essentially behind the scenes, it will do the same thing. It will go and create the clusters. And again, if you're familiar with Terraform, one question is how you use or how you set up the Terraform state. And the magic thing here is that I have already gone and connected, like I did this before the webinar, the real cluster, my parent cluster. I connected it to Codefresh so that Codefresh knows about it. So if I go into this screen, right now Codefresh knows about the parent cluster. I've named the real cluster so that it's clear which clusters are real and which are not real. You can imagine next we will add virtual clusters. So this cluster is here once with authentication. And then this makes my pipeline super easy because I can just say, go to this cluster and deploy something, or use it as a Terraform state just by name. So this is what happens in this step. Here, if you see the YAML from this step, it just says use the real cluster and then do whatever you want. So this has created the clusters. I have created 4 clusters in 15 seconds, okay, which is super fast. And then just for fun, I'm also using the CLI to verify the clusters. So now I have 4 clusters here. And again, you can imagine I had 20 clusters or 25 clusters. So what have I gained now? Now I have gained the capability to also work in a GitHub style. Because I'm not using my local workstation, I have actually this example in this GitHub repo that I mentioned before. So this example is in multiple clusters remote. And here I can start a Git workflow. So let's say I created these 4 clusters for my developers. And then one of the developers says, hey, we need 2 more clusters. Okay, what do? I do what every, let's say, developer would do. I can come here into this file that defines the number of clusters, remember the count, and I say, okay, this team needs now 6 clusters. Okay, so I change 4 to 6, and I can commit the change. I'm not going to commit them here. Maybe I will create a new branch, and I will name it 2 more clusters. 2 more clusters, proposed change. So I have now created a pull request, and then you can follow the workflow that you have in your company for your pull request. So maybe, in your team, somebody needs to approve changes in infrastructure. So you can assign this to your team lead or the other team and say, hey, I'm going to do this. Do you agree? And the magic thing here is I have created a second pipeline, because unlike some products that I'm not going to name, CodeFresh has the capability to have multiple pipelines for the same repo. And this is a separate pipeline that says preview. And essentially, it's similar like this. But if you are familiar with Terraform, instead of running Terraform apply, it runs Terraform plan. So this will run, and it will not actually do anything at all. It will just say what will happen if I will merge this pull request. So this is the one that is running right now, but we can go to one of the previous ones. And if we look at the log, there it said, I think this was the same example, hey, I'm going to add 2 more clusters and change your clusters. So not only I have a pull request here, but I actually get some indication of what will happen if I merge that pull request. So from this point onwards, even operators, are happy because they don't have, let's say, to communicate and say, hey, I'm going to do this. Do you agree or not? You can work with Git and Terraform exactly the same way as you want. And just to close this example, we can do the same thing as before. There is a pipeline that does Terraform destroy. So after I'm finished, let's say my developer says, I don't need these clusters anymore. I can run the pipeline, and then it will use the same Terraform state using the parent cluster, and then it will destroy the clusters after it's finished. Okay, so we don't need to wait for this. Let's go back to the slides. Okay, so we have seen how you use Terraform in the pipelines in CI. So we have talked about the basics, the building blocks. Let's finally see a real world example. Okay, enough with the demos that show one small thing and one small thing there. Let's see a real example. And the example I've chosen today is developer onboarding or creating a new service. This is the scenario where a developer says, okay, we have a need for creating a brand new application. Maybe it's a new microservice, or maybe it's a brand new application, and they need all the stuff that they can work. And remember, this scenario is interesting both for developers because it affects their daily job, but also it's interesting for DevX people because they want to see developers move fast and understand how fast the team is deploying and how fast the team can create a brand new service. So usually what happens in big companies especially is that the developer says, I want to create a brand new application, and then they need to create an inventory of stuff and say, okay, what do I need? I need a Git repository for my source code. I need a cluster to deploy my application. Maybe I need a second cluster for a unit test, integration test. I also need a pipeline. I need a Docker registry. I need a way to access the Docker registry. And then they start collecting these things. And maybe big companies, it's a different team. So first they go to the GitHub team and they say, give me a repository. Then they go to the Kubernetes team and they say, give me a cluster. Then they go to the, let's say, Docker registry team and they say, I need access to the Docker registry. And this can be, let's say, a super lengthy process. Maybe you need to open some tickets to people and say, I need a cluster, and then wait for somebody to look at the ticket. And then finally you get the cluster, and you get the cluster, but you don't have your pipeline and you are blocked. So this is a very common scenario that I see in a lot of companies where, working in an existing project is super fast, but trying to create a new microservice is super slow or a new project. So we don't want to do this. What do we want to do instead? We want to create everything in a single step. So ideally, you should go to one person, say, hey, I'm starting a brand new project, and they will run something, a single button, a single script, a single Terraform file, doesn't matter. And then it will create everything that you need and get back to you after 5 minutes. Yes, this is possible. And this is actually what we're going to see in the demo. And remember, I said before that, Loft, like the dashboard, covers effectively the local development, like I'm a developer and I'm working, but just getting access to a Kubernetes cluster is not enough for an application. You also need deployment pipelines and GitHub repositories. So in all the previous demos, we have seen some of the building blocks. So what do we need? We need a GitHub repo for the source code. We need some clusters, and we have already seen how we can create virtual clusters automatically and very fast. We also need a deployment pipeline, and we have seen Codefresh pipeline, but not pipelines that deploy code and compile code. And then we also need a bootstrap process for everything. And as you can imagine, we are going to use Terraform because Terraform is great for this process. So we have seen that Terraform has a provider for Loft. Terraform also has a provider for GitHub. And essentially, it allows you to create a new GitHub repository. And the simplest thing you can do is you get a template repository. This is a built-in feature of GitHub where you have, let's say, a starter application or a skeleton of application. And usually, maybe it's approved by your architects or by your team. And they say, this is how a new microservice should be written. That's the starting project. So you can use that repository. So, don't imagine that we are going to create a repository from scratch, adding files manually. This would be too lengthy. We're going to take a template repository and copy it. So this part is covered by Terraform. Then there is also a Terraform provider for Codefresh, naturally, because we also love Terraform. So the pipeline that you have seen before, I created manually, but Codefresh has a way of creating automatically pipelines, like programmatically, without me actually going into Codefresh and say, hey, I want a new pipeline. So as you can imagine, we're going to create a pipeline for developers for compiling their code and deploying the clusters. And this is what we are going to do. We're going to create a master pipeline in Codefresh that itself is creating everything that the developer needs. So it will create a GitHub repo for source code. It will create virtual clusters, as we have seen. It will create pipelines in Codefresh. So this is a pipeline that creates pipelines, okay? It will connect the clusters to Codefresh. And then after we finish, we will say to the developer, okay, everything is ready. So this is the magic button that we are going to push. This is how it looks, the pipeline. And let's see the final demo, the most complex one. Hopefully it will work. So just before I start, I want to show you some important things. First of all, I showed you the cluster integration screen where you say to Codefresh which cluster you have. And right now, I'm going to show you that there is only one cluster. It's the real cluster. Okay, that's the only thing that Codefresh knows right now. I'm also going to show you my connection to Docker Hub. So I've already created Docker Hub connection here. So the pipeline I'm going to create will say, let's compile the code and push it to Docker Hub. And developers don't need to know anything about how it works and how it's authenticated. And the last thing I'm going to show you is Codefresh also has a dashboard for environments, which right now is completely empty. It doesn't have anything at all. So the thing I have done here, by the way, the other demo has finished and the clusters are destroyed. So here I have already gone ahead and created, let's say, a repository, which is my, let's say, template, the starter project. This is a Go code. And let's assume that in my team, I have agreed and say every microservice should be written with these files and these things and these pipelines. So this is my starting point. And then I'm going to go to my Loft demo project here in Codefresh, and I will click the most complex pipeline ever. Create everything. Yes, this is why I called it like this, create everything. So let's run it. So essentially, this is the scenario where, I'm an operator and the developer comes to me and says, hey, I'm creating a brand new application, give me everything I need. And the only thing I do is press this button, nothing else. Now, while it's running, I'm going to show you a bit the code. I'm not going to go into too many, Terraform details because this webinar is not about Terraform, but essentially it has 3 clusters. Let's assume the developer will use QA, staging, and prod. And this is how I define them in Terraform. And actually here I'm taking advantage of the feature I mentioned before. So just for fun, you can see this cluster is K3S, while this cluster is K0S, and this cluster is standard Kubernetes. So if a developer says, I want to test different Kubernetes versions, they can do it just fine. Then I have some manifest, which have standard things like ingresses for exposing the clusters, which I don't think it's important right now. And then these are the pipelines. So even though I clicked a button, behind the scenes, everything is stored in Git, and I can follow the exact same procedure later if I want to change something. So if I want another cluster, I can go and create a pull request. So like before, we start and we say we're choosing the real cluster. This is I have named like here. So this is the real cluster. And then I'm creating the virtual clusters. And in this case, they will take some more time because I'm also creating ingresses for them. So they are going to be externally accessible if a developer wants to work there and connect their application. Then just for fun, I'm also going to create the virtual clusters. And then the rest of the steps are Codefresh specific, which for this webinar are not really that important. It's this. This is not, let's say, a good thing to do in production. It's essentially the privileges and the RBAC controls that you give to Codefresh what to do in the clusters. Because these are virtual clusters, remember these are virtual clusters that I'm creating, essentially I'm saying be an admin and do whatever you want because I don't really care. They are virtual. And then the final thing is making Codefresh aware of those clusters. And then, as I said, create the pipelines that developers themselves will use. So remember, this is the pipeline I use as an SRE, but I want also to give access to a developer for actually building the application. So this has finished. So you can see I created the 3 externally accessible clusters with ingresses in 1 minute and 30 seconds. Remember, I said that usually in a cloud provider, you need 15 minutes at least for creating a real cluster. Now in 1 minute, I created 3 clusters, and then I can say to the developers, do whatever you want. So the rest of the process will finish super fast, I think. You can see the timings here. And after this is done, we should also see, after this step is done, we should also see that now Codefresh is aware about the new clusters. So I'm going to visit the integration screen of Kubernetes that we saw before. If you remember, it was only the real cluster. But now after it finishes, let's see, it finished some of the clusters. I can go here into my settings and look at now the clusters that are known to Codefresh. And if I go now to clusters, you can see that now Codefresh knows about 4 clusters. And I've named them, just to be clear, this is the real cluster, the parent cluster that has everything. And these are the 3 brand new clusters that I created, and they are completely virtual, and Codefresh knows how to deploy. So now I can do everything I want with Codefresh, and these clusters now are available by name. So a developer can say, hey, I want to deploy to this cluster named prod, and they don't care about kubeconfig files or authentication or anything else. So let's see if everything else has finished. Okay, so now it has finished. So if you go now to GitHub, there should be a brand new repository, which is for developers, and this is my Loft app. And also in Codefresh, there is a brand new project. So you see, this is the project I was working, and now there is a brand new project that was created automatically, and this has the pipeline for developers. So now I say to my developers, hey, I'm done. Now you can deploy your application, and this is a normal standard pipeline that I'm going to run that takes the source code of the microservice, compiles it, pushes it to Docker Hub, and then, as an example, I'm deploying it to the QA cluster. And in a more complex example, I would create more pipelines that promote things from QA to staging to production and to the other things. So this is what I did as an operator. This is what I did behind the scenes. You can see it took me like 5 minutes, and without opening any ticket, without any lengthy process, I say to my developer, "Hey, your GitHub repo is fine. It's ready. Here is your pipeline for deploying." And now the developers can focus only on deploying code. So they can check out the repository, they can make a change, and this pipeline is already set up to run automatically for them. So as soon as they make a change, it will be deployed to the QA environment right away. So everybody's super happy. Developers got what they want. As an operator, I did, let's say, a super quick action of just clicking a button. Everything is stored in Git. There isn't, any fancy API. I know exactly what is in the cluster. I know exactly what is in the pipeline. I know exactly what goes where. And then if somebody asks me, hey, how much time it takes for a new microservice to spin up, I can say 5 minutes. And not just me, I mean the developer as well. So this will take some time to build Docker image, but this is actually the end. So I think we can go back to the slides. So that's it. That's the end. I think the last example was the most realistic one. Everything I've shown is on the first link, the Terraform Lab. It has all the 4 demos that you have seen. Bcluster is the website of Bcluster, which has a lot of ways, how to use it and documentation. The third link is how you install Loft for developers. And then the last 3 links are for the Terraform providers that you have seen today. And on the left, you have also 2 links if you want to know more about Loft, like the commercial product, or Codefresh, the commercial product. And that's it from my side.
All right, Costas, that was great, and we already have some questions. So here is the first question, and I will just read it out loud. Are there pre-made cluster templates that we can add to our Loft account and modify? Can we manage them with Ansible playbooks?
So yes, I didn't show this. Maybe if we go back to the demo, here there is a whole section for defining templates, and Loft gives you one template out of the box, which they call isolated, and it's a bit, let's say, better for security. But here you can create your own and do whatever you want. There is also a capability to pre-install some things in clusters. So if you want to say that every virtual cluster should have Nginx and Cert Manager, you can do it. Now, regarding your question about Ansible, I'm not the proper person to answer this, but I already know that Loft has an API for all this. So I'm assuming you can also use Ansible to call the API, or if too many people ask, they will say, okay, we already created a Terraform provider for Loft. Let's create Ansible playbooks. But this is a better question for the Loft team. The main capability of creating templates and pre-installed application in clusters is already there.
Got it. And for all the questions, one of our teammates, Rich, he's kind of typing some answers in the chat. And if you have more questions, you can also join our Slack community, slack.loft.sh, and then you can join the vCluster channel and you can ask the questions. And Rich has been already answering some questions, but I will take one more question from Sukhen Kumar Tiwari. Here is the question, Costas.
So the question is, can you explain the role of automation and infrastructure account is managing virtual clusters? So this is a super interesting question, and essentially it comes back to where the job of the SRE starts and where it ends. Some people think that infrastructure as code should be only, infrastructure, like creating Docker registries, clusters, load balancers. And then if you're working with applications, you should do something else. And a popular answer there is to use Argo CD. Well, there is another, let's say, idea that I try to show this today, where you say everything is infrastructure. So even virtual clusters is infrastructure, pipelines is infrastructure, GitHub repositories are infrastructure, and then you say we manage everything with Terraform. There isn't right or wrong answer there. It depends on what your company would do. I would say that if you are in a big company, maybe it makes sense to split some priorities and say not everybody needs to learn Terraform. Maybe, after I create a cluster, a virtual cluster should be created with something else. But if you love Terraform or Pulumi or Crossplane or Ansible, and you are in a startup, maybe you say, I want to manage everything as infrastructure as code. So that would be my answer.
Got it. And then Costis, I know we are already over time. Um, any thoughts on production multi-tenancy with vCluster in terms of any examples you have seen in the market, how people are using it? Any comment on that production multi-tenancy?
So actually, this is a perfect question because this was the use case that we presented at KubeCon. So we at Codefresh are using vCluster for multi-tenancy in production. We use it to power our hosted Argo CD instance, and it's this one. The first link here is exactly this: how we use vCluster for multi-tenancy in production in a KubeCon presentation. So it exactly answers your question.
Got it. Perfect. So I will make sure to send out that link to the registrants. All right. Uh, any last minute thoughts? Anything you want to add?
I would like to say that we haven't seen yet all the interesting use cases for vCluster. I think it's just the beginning. People are learning about the project and they are discovering and say, oh, can this help my process? And some companies have already adopted it, but I think we'll see more companies finding new use cases and explaining more about vCluster. As I said, remember the slide about the Swiss Army knife? I think it's a great product that can be used for many use cases. Some of those that even the Loft team doesn't know yet. Like people will be amazed with what companies will do.
Yeah, agreed. And it's been great so far in terms of growth in vCluster, and of course, CodeFresh, Argo CD are uh, kind of backing us in terms of like using it, and like you're doing webinar and you're giving talks in KubeCon, so that's great, and there will be a lot more use cases for sure. All right, everyone. So that's it for today. Thank you, Costis. Thank you so much. Few last things. If you have any more questions, as I said before, join slack.loft.sh. You can also go to loft.sh and get started. You can kind of try our product. If you have any specific use case, you can request a demo. And same thing with CodeFresh. You can go to CodeFresh, request a demo, and they will be also happy to give you a demo. And all the links in the presentation, the GitHub repos, um, the KubeCon links, we will send it out in an email. And regarding the recording, we will also send that out. But because this is a LinkedIn Live, this video will stay here so you can come back and watch it. So with that, thank you so much, everyone, for joining us, and see you next time. Thanks,
Thank
Costas.
you. Bye.
Bye.